All right, Jamal says that since there are 40, we're still in Unit 8, right? Am I remembering right? We want to finish up 8, yeah, and start 9. So this is homework 8, Unit 2, homework 8. So we're finishing up homework 8, right? Last time we did the investment problems, right? I wrote that big formula on the board. So if you didn't get that, check out the YouTubes from last time. That was a big formula that you need from the YouTubes to do the last 3 problems, 14, 15, and 16. But I don't got time to back up. I got to move ahead. So Jamal says that since there are 46% girls at Washington School and 54% girls at Jefferson School, there must be, that word's important, huh? Okay, there must be more girls at Jefferson School. Is he correct? What do you think? 46% girls at Washington School, 54% at Jefferson. Jamal says, therefore, there must be more girls at Jefferson School. True? False? False. Why? Why is he not right? Why false?
Because it depends on the amount of students at each school.
Yeah. Percentage is just the portion, right? So Jefferson School might have a higher percentage of girls, but if Washington has 10 times as many total students, or even double as many total students, they would actually have more girls even though their percentage of girls is lower. So I don't know which one of those says that. Oh, to show Jamal that there could be fewer girls at Jefferson, use an extreme example with the total number of students at Jefferson School is much greater than the total number of schools at Washington. Yeah, that's right. For example, if there are 100 students at Washington and 1,000 at Jefferson. Yeah. Why is the other one wrong?
Washington has more students. So it's flipped. The schools are flipped.
Oh, do they flip them? Oh, they had 1,000 at Washington. Yeah, that wouldn't work, would it? Wait, which way do we want it? Oh, yeah, we want more. Yeah, I'm getting confused. This is the right option. We want more at Washington to prove that there could be more girls at Washington even though the percentage is lower. So it's this one, right? 1,000 students at Washington and only 100 at Jefferson. That's the way we want it, actually, not the other way. Do you see that? So the way you would prove Jamal wrong, mistaken in his thinking, is you would actually say, well, look, Jamal, for example, if you had a whole bunch of students, 1,000 at Washington, even though there's only 46% girls, how many actual girls would that be at Washington?
460.
Yeah, 46% of 1,000 girls at Washington. So at Washington, if there was 46% girls and there was 1,000 girls, 46. What is of always in math? Multiply. So that would be 0.46 times 1,000, which is the 3 zeros just moves the decimal 3 places, huh? So just go 1, 2, and the third jump does what? What happens when you go when you move a decimal beyond the edge of a number? Right, you add a 0, huh? So that'd be 460 girls at Washington. Whereas if Jefferson only had 100 students, and they were what, 54% girls? So then 0.54 of 100, meaning times 100, right? That would come out to be 54 girls. So there'd be 54 girls at Jefferson, but 460 at Washington, for example. So even though the percentage is lower, that would prove there's more to the story than percentage. All right. I think you know that. A student says that 4 to 4th percent is 0.04 plus 0.25 is 0.29. Is this correct? What do you think? 4 and a 4th percent. Because this is that's 4%, right? 0.04, isn't that 4%? And a 4th, you guys know what a 4th is, 0.25. .29. Is that correct? Got some little whippersnapper in one of your classes that says that's the truth. Isn't that right? What do you say? You say, you're bugging me, kid. Quit asking me these dumb questions. Go out to recess and play. Yeah, Cammy.
Wouldn't that not be right? Because you say you have 4% and then another fourth of 1 whole percent. So if you say that 4%, you're not adding another 25%. You're adding a 25th of 1%.
What do you think about what Cammy's saying? Cammy's just always right? So I hope you don't check out when Cammy talks. I think we're getting that dynamic in here. When Cammy speaks up, everybody says, well, she's got the answer. We'll just let Cammy speak. I appreciate Cammy's input, but I don't want the rest of you to check out. See? I haven't even looked at the options, honestly. The student is not correct. I don't know.
I never saw that.
How about I don't even know about ABC yet. How about we talk about what Cammy said? What do you think? Did you hear what Cammy said? Is it true? What did she say? Cammy, what did you say again about the fourth?
I said it's not saying that that's 1/4. It's 1/4 of 1%. And the decimal that they put would make it 25%.
Yeah, 0.25. What is, I'm throwing the mouse here. What is 0.25? That's 25%. Yeah, that's not a fourth of a percent, is it? 0.25 is 25%. Cammy's right? So that can't be right. A fourth of a percent is not the same as 25%. But wait a minute, we know a fourth is 0.25 though, right? That's true decimal-wise, isn't it?
Place value.
So what's going on? Yeah, some kind of place value thing?
It's missing.
What should it be?
It should be in the thousands.
Should it?
The hundreds.
So it should be 0.025, you're saying?
Yeah.
A fourth? So you're saying, so let me just move it over here. So the whole issue is the fourth of a percent. Well, forget about the 4. We all know the 4 in the front. That's not a big deal. The question is, what is a fourth of a percent? So you're saying it's not 0.25, it's 0.025. Is that what you're saying? Mm-hmm. Is that true? How do you know?
Always use your calculator.
My calculator told me. Yeah, the calculator knows. This could be on the non-calculator part of the test. How do you know? Is that right? Okay. Is that what the calculator told you? How about we don't check the calculators for a minute? I don't think the calculator told you that. Unless the calculator is broken. Because that's not the right answer. 0.0025? What?
Because if you move it over to be like a percentage-wise, it would be 0.25%.
Okay. So you're saying, hey, take this thing and make it 0.25%. Is that what you're saying? And then, I thought I was doing what you were thinking. Okay. And then,
That's 1/4. I don't know.
yeah, is it? Is 1/4 0.25? Yeah. And then how do you get from here to here? Yeah.
Well, I just think of it as moving the decimal, but I mean.
Yeah. Yeah, and right. And why? Remember what percent? Remember what we were talking about percent means? What does percent mean? Per 100, meaning divide by 100, huh? So if you take 0.25% and divide by 100, decimal goes back 2 places, right? It gets smaller when you divide by 100. So yeah, that's got to be right, huh? It's 0.0025, isn't it? That's what 1/4 of a percentage is, right? Yes, 1/4 is 0.25. That's true. But 1/4% is 1/4 or 0.25 per 100. So divide by 100, 2 places back, huh? So it's got to be 0.0025. So then going back to the original question, what was the original question? 4 and a fourth percent. Oops, I'm getting kind of scribbly there. 4 and a fourth percent. So that'd be 0.04, right? We all know 4%. That's 0.04. And now this one's 0.0025. So the answer is 0.0425. You add those up, right? Line up decimals. That's the real decimal, isn't it? Does that make sense on that? So the whole trick, where you get confused, is we tend to think 1/4 is just 0.25. If it was just plain 1/4, didn't have a percent symbol, then yeah, 1/4 is 0.25. But it's 1/4%. And that means something. Huh? That's what I've seen over the years, is that sometimes students treat the percent symbol kind of like a decoration. It's like an ornament on a Christmas tree. You don't want to treat it that way. Percent has a meaning. When it's there, something is meant. And when it's not, that thing is not meant. So remember, percent means per 100, right? So 1/4% is 0.25, that's true, but it's percent per 100, so divide by 100, yeah. Good work. Back 2 places. That makes sense? So that's the trick. I don't know whether that's A, B, C, or D. Yeah, I think it is C, huh? Isn't it C?
Yeah.
Not correct, and they want us to go 0025 there, right? Which is 0.0425. Everybody see how I got that? I just lined them up. Just added up, straight up and down. So I got 0425. Is that good on that one? All right, so these are like little trick things. Noel read that women used to make 75 cents for every dollar. Noel, this is your baby here. 75 cents for every dollar that men made. Oh, sorry. She says, this means that men were paid 25% more than women. Is she correct? So women were getting 75 cents for every dollar that men made. So men were getting 25% more. Is that true? Nobody knows. What do you think? 25% more. 25% more. How do you do 25%? Yeah.
It's wrong, I think.
Why is that?
Because it would have to do 25% of what she's making.
That sounds right, yeah.
And 25% of 75 isn't going to be 25 cents. So she was really trying to say that they make, I think, 33% more. Because if you take a third of 75, it's 25.
Nice. Everybody hear what he's saying? Right? That makes sense? That when they say what it means to make 25% more than what? More than her current amount, right? So if you take an amount, say you take $100, and you say, I want to increase that 25%. How do you increase that 25%? What's 25% more than that? Well, you've got to go times 0.25, right? And then you get the answer, $25. And then that's not the final answer, though. Then what do you got to do? So $25 isn't 25% more than $100. What is? 125, right? So we got to add back the original 100. So $125 would be 25% more than 100, for example. Right? That's what he's saying. He's right? That makes sense? So in other words, to increase something by 25%, what do you got to multiply it by? 0.25. Did we talk about last time how you can throw a 1 in front? No? I really thought we did, but looks like I'm wrong. All right, let's talk about that. Yeah, so think with me for a second. If you take $100 and you want to increase it 25%, you could multiply it. I think you could all do that with your calculators, no problem, right? You just multiply by 0.25, get the $25, but then you got to add back the original, huh? And so you get $125. That's the $100 increased 25%. Well, how could you do that in one step? You could take the $100 and instead of multiplying by 0.25, which will just give you the increase amount, then you got to add back the original to get the final amount, you could just throw a 1 in front of that. And you'll get straight to the $125 option. You don't need 2 steps. Just boom, straight to it. You ever seen that before? Just throw a 1 in front, and that gives you everything all at once. The increase, the original, the whole final thing. Why does it do that? Like, you know, right, about multiplying by 0.25, you get the $25. That's the increase, then you got to add the original and you get that. Why does throwing the 1 in front give you back the original? See, that's what it's doing. You know the 0.25 is the increase, but why does the 1 give you back the original? What is 1 times 100? It's 100. That's the original. Does that make sense what's happening there? That just gives you the original, and the 0.25 gives you the increase, whole thing at once. Does that make sense? So, for example, what if you're buying something? You say, I was really wanting to buy whatever, and it was $89, and then there's 8% tax. And I'm wondering what the final price is going to be with tax. So how could you do that? Well, you multiply by 0.08, and you'd get whatever the tax amount is. Then you would need to add the original $89, and you'd get the final price. Right? But what could you do to be much quicker with your calculator? Just, instead of multiplying 89 by 0.08, getting the tax, adding back the original 89, you would do what? Just put the 1 in front. Does that make sense? If you just put the 1 in front, 1 times 89 will give you the 89 back, and the 0.08 will give you the increase, give the whole thing all at once. Am I making any sense? We're about to use this a bunch. Is this making sense? When you put that 1 back in front, you know, I remember. I always remember when I was going to college way back in the 90s. Every summer I was in college for 8 years. I was not the fastest at getting out of college. 8 years. Anyway, every summer I would do some kind of summer job, and to make money. And the jobs got better and better as I got more degrees. And I remember my last one. I worked for PG&E over the summer in Cal Poly, San Luis Obispo area. Worked at, and I took bill payments. I was one of those window, just for the summer, take people's payments. Came in, and we us window collector people, all the time, we would have somebody have a PG&E bill, $89 or whatever, and we would need to do the tax on it, and we take our little calculators and we do the tax rate, whatever it was there in San Luis Obispo County, do the tax and add back the original and tell them their price, their bill, and then they pay their bill. And after a while, we do this all day long. And so after a while, I was like, well, this is silly. Let's just put a 1 in the front, and boom, we just get straight to the 5 because the 1 will give I did this. And I thought I would share that idea with my fellow window workers, But you got to understand the environment there. They were full-time, that was their career job. And I was the college kid, just there for the summer. So every summer I had some college job. Anyway, so I remember I shared, hey guys and gals, I said, we don't need to do this so hard every time. When they give you the amount, instead of multiplying by the tax and then writing that down and then adding back the original in the 2 steps, just put a 1 in front. And they're like, no, you can't do that. I'm like, no, let me show you. So we did a little example, and I said, see, okay, do it your long way. Okay, now do it again and put the 1 in the front. And they were like shocked, I remember. And I'm like, see, that'll work. It'll save you a lot of time. And they're like, no. They're like, I don't know what that college trick was, but I'm not trusting that. I remember they thought it was like I was doing sleight of hand from college. And I was like, oh, okay, you don't have to do that. It was just funny to me that it was so amazing to them. So anyway, just put a 1 in the front, and you get the whole thing. Don't pay attention to the bug I feel like Wizard of Oz. Pay no attention to the man in the front. All right.
Is that where the 1 in that compound interest formula you gave us comes into play?
Yeah, that's right. That is where that 1 comes from. And we'll talk more about the 1 in a little bit. All right, good. So with that in mind, I called everybody's attention to the bug now, huh? All right, so with that in mind, I'm not helping. Let's get back to it. So in other words, what you're saying is right. If you want to take the 75 cents amount and increase it 25%, how would you increase it 25%? You would multiply by 1.25, which is the same as what percentage? 125%. That's what 1.25 is, right? What is 125%? Remember, per 100 divided by 100 is 1.25, isn't it? You tracking with me? Those are the same thing. So what they're saying is not correct because 0.75 times 125%, or 75 cents times 1.25 decimal, is, I have no idea. Does somebody have it on their calculator? 0.9375. In other words, it's not $1. It's not $1. Is that making sense there? And what Eddie, right? Eddie, was right also about what percentage increase is this? 75%. What percent more were men making? How to take 75 cents and turn it into $1? What part of 75 cents do you need to add to get $1? You got to add 25 cents, right? And what part of the original 75 cents is that? What part is that? Did you hear what Eddie said? It's 1/3, huh? 25 is 1/3. So men aren't making 25% more. They're actually making 33% more, right? 1/3 of the original. All right. I promised there'd be like 3 or 4 questions that where you don't use your calculator. It'll be these mainly. It'll be these. So take note. These are really important for exam number 2. The no calculator. You need to be able to do these with no calculator. Basically, I want to help you to convert between percentage decimal fraction. Remember I said last time I did the cup example, right? And I said this cup right here is, this is water here, is half full of water, 50% full of water, or 0.50 full of water, right? Percentage decimal fraction are 3 languages to say a portion, aren't they? Like 1, uno, and 1 in some other language, right? They're just 3 different languages to communicate a portion of something, part of something. That's what they are. So I want to make you fluent. Make sure you are fluent. I think you probably are. But I want to make sure you're real comfortable with translating between them. So let's start out. So they're going to have us go all different directions here. So write each of the following is a fraction. So let's start with 19.56. How do you take 19.56 and make it a fraction? So question 20, we're making everything fractions. 21, we're going to make everything percentages. So how do you make a decimal, 19.56, into a fraction? The 19 is just 19. How about? And the 0.56, what's the 0.56? As a fraction, I mean.
Wasn't they last time over 99?
Oh, good question. Yeah, the 99 stuff was when they went forever. Yeah. So like if you had 0.56 bar, which is 56 forever, that's 56 over 99. Good question. Probably other people wonder the same thing. So that making sense. The ones that went forever was over the 99. That'd be 56 forever. So what's just plain 50 is just 56 stops, it doesn't go forever. 56 over 100, right? Because remember, it ends in the hundredths place. Remember, it's always by the ending spot. This is the tenths place. This is the hundredths place, right? So wherever it ends, that's 56 hundredths. So that's 19 and 56 hundredths. But notice something. That's true. What we wrote is true. But notice how to do it even more easily. If you now wanted to convert this into a normal fraction, how do you convert a mixed into regular? Because they're asking me for regular, right? They don't want mixed. See what they want there? They want normal fraction, not mixed. So how do you convert this into mixed? I mean, it is mixed. Into regular. Multiply the bottom and add the top, huh? Remember that? So what's 19 times 100? Well, 1900 plus 56 over 100, which is 1956 over 100, isn't it? Did y'all see that? Right? So 19.56 is 19 and 56 hundredths. And then when you convert it, you multiply the bottom, add. In other words, look at the final answer. What could we have done to save a little time? We could have gone from 19.56 straight to just put the whole thing over 100, huh? It ends up being that way anyway. So you don't have to do that in between stuff. Everybody see that? I wanted to show it to you, though, so you knew why. So you can just go right here. Actually, that needs to be reduced, though, doesn't it? Divide by 2, top and bottom on that one. Somebody got that? My calculator? I'm not sure I can do it. 959. What is it? 978, thank you. Over 550, Over 50. I guess it's divisible by 2 again, huh? 450 and 485. 489? All right? 49 over 25. And that's as far as it'll reduce. So there it is. This first one is 489 over 25. Question, comment?
So when you do this on the test, are you just going to have to do it like long division? Since there's no calculator.
Yeah, right. Reduce those, yeah. So you'd have to reduce that by hand, that's right. So, right, so you would just go 2 into 1956 by long division. That's right. That's right. Just do it by hand. So that would go. Remember how to do that? It's been a while since you did long division by hand. 2 times 9 is 18. Bring down the 5. 2 times 7, 14. 1. Bring down the 6. 978. Yep. Just do all those by hand. That's right. Want to try the next one? Try part B. 0.005. Change that one into a fraction. In fact, why don't we just do B, C, and D? So how about, all right, let's dive in. Okay, so what do you think about, we're at 0.005, that one? So 0.00, no, yeah, 2 O's and a 5. That O in the front doesn't matter, huh? You can just ignore that, it doesn't do anything. 0.005, so that is 5 over what? 1,000, because it ends in the thousands place, right? 3 places to the right means 3 zeros on the bottom. We good with that? And then you just got to reduce that, huh? And so divide by 5. Top and bottom is 1 over 200, right? You can long divide 5 into 1,000 there. So down here, 1 over 200 for that one. And then part C is negative 7.93. So that's negative, what do we do? Over 100, huh? Because again, it's 2 places after the decimal, which means 2 zeros down below. And that doesn't reduce, huh? How do you know right away there's no way that reduces?
It's not divisible by 2.
2 or 5. Because remember, 100 is just made out of 2's and 5's. Remember, it's 10 times 10, and 10 is 2, 5, 2, 5. So, you know 2 doesn't go in, you know 5 doesn't go in. So that's not reducible. Minus 793 over 100. And then part D is going to be what? 0.753. 753 over 1,000. And again, that's not reducible, huh? 753 over 1,000. So that's pretty easy. Decimal to fraction. All right, how about down to 21? Changing mixed number and regular fraction to percentage. All right, so without a calculator. So how do we do it? How do we change 3 2/5 to a percentage? How about I let you think about it on your own? Looks like there's a lot of different ways to do this that are correct. So let me okay, so 300 or 3 2/5. They want me to change that to percentage. So how about this? Now, there's a lot of good ways you could go. I saw a lot of good things. A lot of y'all I was noticing made the bottom 100. That's a good plan. Because that's what percent means. I'm glad you're thinking that way. Percent means per 100. I think it might be easier. So I'm not going to do it that way just because I think it'll be easier in the long run to just do the following thing. That is just to make it a decimal. So I'm just going to straight make it a decimal. And I think it's easy to go anywhere from a decimal. Even though I don't want to negate what I saw a lot of you doing is really good. A lot of people just took it and they just multiplied. Well, I won't, they did a good way. I don't want to confuse everybody by doing 2 ways. So anyway, so I'm saying just change to decimal. So, and then I think it's easy to get anywhere from a decimal. That's like the easiest of the 3 forms. So if you just make it a decimal, it's easy to leap anywhere. So how would and we know the 3, that's just 3, But how about the 2/5? How do we make 2/5 into a decimal? So this is my suggestion. Number 1, make it a decimal. Decimal. Make into decimal. Yeah?
If we're used to the way that we do it, is that okay on the...
No, Jenny, I'm going to mark it all wrong. No, I'm totally good with any way. Any way is fine. Yeah, so any way is fine. So, but my way is best. No, you don't have to my way. So how would I turn? Yeah, so if you've got a good way, no problem. But how would I, if you're not as comfortable, let me show you a good way. So how do I turn 2/5 into a decimal first off? Divide, right? It's bottom into top. And of course 5 doesn't go into 2. So you make it 2.0, which is still 2, but now I can do it and it'll become a decimal. Remember how that works? So to turn a fraction into a decimal, you just divide bottom into top. Of course 5 doesn't go into 2, so you make it look like a 20, but that's really still 2, isn't it? Right? And then 5 goes into 20 4 times. Remember, you always put the number over the last digit of what you're going into. and the decimal goes straight up. So 4 times 5, 20, done. So 0.4. So 3 2/5 becomes 3.4. So step 1, make it into a decimal. We did. There's step number 1. It's a decimal, 3.4. Now step 2, make it into a percent. Because it's still not a percent, is it? It's still not a percent. But it's pretty easy to get there from a decimal. That's why I think going to decimal first makes everything really easy. So how do you make 3.4 decimal into some kind of percentage that, remember, we're doing plastic surgery, remove the wrinkles, same person, right? Can't change the value, just change the way it looks. So what do I do to it to keep the value, yet I'm going to put a percent here. So what is it? Yeah, 340. Does that make sense? How do you know that's right? Well, because 340 per 100 means divide by 100 means the decimal back 2 places is the same as 3.4. So this is the same as 3.4, isn't it? Because the percent means divide by 100, decimal back 2 places. So 340 divided by 100. That's what that basically says. You with me? You getting more and more comfortable with percent? That's why it has it divided. You ever wonder? I mean, the symbol is an excellent symbol in the sense that it tells what it is. It's divide by 2 zeros. It says divide by 100 right in it, huh? That's what it means, per 100. So 340 divided by 100, yeah, that's 3.4. So we good there? Does that make sense? So again, there's other good ways. Some of y'all made 100 on the bottom. That was a nice way too. This will be easy for everything. Yeah?
So the 3 stays the same, and you only divide 2 by the 5? And the
Yeah.
3.4?
Yeah, good. Yeah, the 3, good question. The 3 is just 3. Diana, right?
Yeah.
Diana. Yeah, the 3 is just 3.
Changes or nothing, like it just stays? Like
Yeah, I just leave the 3 there, yeah. Because 2/5 is 0.4, so 3 2/5 is 3.4. Yeah. So then how would we do that on part B? How would we take 8/3, make it a decimal? What do you do? Yeah, bottom into the top. So I'll do part B down here. 8 into 3. 8 doesn't go into 3, so what do? 0.0. And that goes in, what's that? 3 times? Yeah, 3 times. 24. Subtract 6, bring down to 0. Decimal goes straight up. 8 goes into 60, 7 times. 56. 4, bring down to 0. 8 goes into 40, 5 times. There it is, 5 times 8 is 40. So 0.375, 0.375, so 3/8 is the same as 0.375, but not percent. Now I got to make it a percent. Maybe I better get a fresh screen here. It's getting kind of messy. So again, 8 into 3.0 comes out 0.375. And then how do I take 0.375 and make it the same value, but with a percent on the back? What's it going to be? Where's the decimal going to go?
Between 7 and 5.
Yeah, 7 and 5, right? Because 37.5% divided by 100 moves it back. So it'd be 37.5%. Is this making sense? So you always move the decimal twice, huh? When it comes, that's why there's 2 zeros, right? So it moves forward twice when you go into percent, back twice when you come out of percent, right? Same thing, 4/5, 13 over 200. Just long divide and make them a decimal. How about we go down to E? 5 3/4 percentage. 5 3/4. Change that to a decimal. Change that. So let me suggest that you take 5 3/4, make it a decimal first. So let's do that. We're running low on time, so I better make sure I finish this up for you. So 5 3/4%. Okay, so I'm going to take the 3. Just the 5 is just 5, right? No big deal about 5. 5 is 5. 3/4. How do we turn that into a decimal? Bottom into the top, right? Make it 3.0. 4 goes into what looks like 30. Is that 7 times? Yeah. 28. 2, bring down the 0. Decimal goes straight up. 4 goes into 20. 5 times 5.75. We got it. 5.75. That's wrong. I see that mistake a lot, though. What have I done that's wrong?
You took 5% and made it a whole 5.
Yeah, what was I supposed to, what should I be doing? What's the real answer?
0.0575.
Yeah, I forgot to move it back 2 places. Notice, I did great on the 5 3/4. 5 3/4, if the question was just 5 3/4 and it didn't have the percent, if it was just 5 3/4, yeah, that's 5.75. But it was 5 3/4 per 100, wasn't it? It was 5 3/4, 5.75 divided by 100, so the decimal needs to go back 2 places. So watch out. Don't forget that that percentage is there. There's the final answer. 0.0575. Does that make sense? Don't forget, when there's a percent on the end, that means divide by 100. Move the decimal back 2. But after you convert to decimal, then divide by 100. Right? That's what percent means, per 100. Is that good? And so the others are the same. Just don't forget to divide by 100 at the end. Does that make sense? Maybe we better do one. How about we do F? That's all we got time. We're not even going to start the next section. You got 1 minute. Can you do F real quick on your own papers there? 2/5%. Convert that to a decimal. So long divide. It's good to practice long divide by hand there. Bottom into the top. All right, long divide. 5 into 2.0. 0.4, and then 0.4%, which means 0.4 divided by 100. Back 2 places, 0.004. We good there?
Yeah.
So you make a 0.4 and then decimal back 2 places. All right, we finished this up.